Yes. For the wind leeward wall on the back of your building, everything will be the same also, QH, except CB will have different value. So finally, I calculated what is the wind pressure, what is the wind pressure, what is the wind pressure, what is the wind pressure. To get the value on each main system, you have to multiply your wind pressure by S. Because each main system, we have another main system here, we have another main system there. So each main system serves from center line to center line. So your pressure on the area of your building, if you would like to get the value assigned to each main system, you have to multiply by S. So finally, we have frame, single frame with uniform distributed load equal wind pressure on each part time S, distance between each main system. You can get finally a structure analysis problem, frame with uniform distributed load. Sometimes your wind load here is one value, sometimes two value, sometimes three value, based on what is the height of this site.
Can you remind me what the units for pressure is?
Your pressure pound per square feet. If you multiply it by S, will be pound per foot. Uniform distributed load. Okay? QZ using this one, unit. That means the final pressure will be the same unit per area. You need to make it per unit length, so we need to multiply it by distance, which is S between each main system.
Can I ask you a question on slide 6?
I'm sorry?
On slide 6, can I ask you a question?
Yeah.
Why don't we worry about the plan view there? Why don't we worry about those other?
This one and this one?
Yes.
We don't care. Because your main system, our concern is your main system. These forces will not supported by your main system. Your main system in this direction. That's right. So our main concern about main system. Okay?
Yeah.
This pressure will be supported by end gables, side girds at this location and this location.
So how do you decide which side is the windward and which one is the leeward?
Based on your direction of wind. I don't know which direction, that's right?
Yes.
It's a good question. He asked me a very good question. Your wind load is coming from this direction. That's right? Sometimes your wind load coming from this direction. That's right? I have to cover both of them. I need to solve my problem 2 times. The first one, if your wind coming from this direction, what will happen? What will happen if your wind load coming from the other direction? I need to solve every possible situation on your building. Okay? Remember, your wind load is perpendicular to the surface of your building. If your surface is inclined, your wind will be inclined. And for truss also. Finally, this is frame. Under dead load, live load, wind load. We can do our load combinations, that's fine. But if you solve your frame, anybody remember from last semester, what is the internal forces in frame? We remember internal forces for truss, only one internal forces. Which one?
Axial.
Axial force. Axial force or normal force, which is tension or compression. That's all. But for frame, no, go back. Last time we draw normal force diagram, shear force diagram, and the bending moment diagram for each frame. So we can expect normal force, we can expect on each member of your frame, we can expect shear force, we can expect bending moment. So we have different scenario right now to design. You have a column with normal, shear, and moment. You have a beam which is under effect of normal compression, shear, and moment. All of them at the same time. So how to design this, we will cover all of this stuff next time. But today we need to understand or learn how to use RISA.
So, Dr. Elman, which
Which
support
main system?
Yeah, which main system support more pressure? The truss
Support?
system or the frame system?
Okay, so which one is better? Go back to the first or second lecture. I told you truss can cover longer span. If you are talking about 100 or 200 or more, 300 feet without any intermediate column, we prefer truss. If your span width of your area something 100 or below, we recommend frame. Truss is a perfect statical system for large area. We recommend this one for small area because fabrication of all of these members and all of these connections is not easy. But it will be economic if you have larger span. This one is very simple if your area is small and your span is small. Okay?
Okay.
You got it? But in our course, it's up to you. In your project, you can decide this one or this one. It's up to you. Before starting, yeah, do you remember how to define this load? What is the name of this load? Distributed. If you remember in RISA, we have three different types. We have joint load, we have point load, we have distributed load. If you open insert distributed load. So I believe, however, your load is horizontal projection or inclined projection, I don't care. Your load is still distributed load, that's right? So we will define our load by distributed load. Insert distributed load, and we can select these members. But at this one, which called direction, at this one, which called direction, we need to make some change. If you are defining inclined projection, if you are defining horizontal projection, if you are defining something like this. This direction, which direction? Vertical direction? Yeah.
Both.
No, this one not vertical. This one not vertical. This one perpendicular to the inclined member. That's right. So it's not in X, not in Y. So which direction? Let's see. There is a topic in structural analysis we didn't cover before, but for stiffness method, we have something called global axis and something called local axis. What do you think? What is the difference between global gems? Gems.
Yeah.
Are you sleeping? That's right. What is the difference between global axis and local axis? What is the difference? What do you think? Global,
More general.
yes. Local, specific. at only one point. I'm not sure what you mean. Okay, you have a structure with vertical member, inclined member, vertical member, horizontal member, vertical member, inclined member, I don't care. All of this structure has global axis. X axis is horizontal, Y axis is a vertical axis. Capital X, capital Y. This one and this one called global. For the whole structure, we have only two axes, capital X, capital Y. Local axis, no. If you have member like this, we have local axis special for this member only. Your X in the length of your member, your Y perpendicular to your member. If you have member which is horizontal member, your X in the length of your member, your Y perpendicular to your member. If you have inclined member, the local axis for this member only, your x-axis in the same direction of your member, your y-axis perpendicular to your member. So local axis, every or each member has his own axis. X in the same length, in the same direction of your member, y perpendicular to your member. So, if you have member like this, and you choose your direction here, capital Y, your distributed load will be something like this. Inclined projection. And the same member, and you choose your direction small y. What is the mean of small y? Local axis or global axis?
Local.
Small letter x or y means local. Okay, you choose y, local axis. Give me what is the direction of your local axis. I think your local axis for this member, your x, small x, something like this. Your small y, something like this. So if you apply your direction in y, your load or your distributed load will be perpendicular to your member. What will happen if you choose here Py? Py means projection in y direction. That means your load will be something like this. So, when you are defining your distributed load, you can choose which case you are working on based on direction. If you open this one, you will find many options. One of them, capital Y, which is the normal direction in vertical direction, inclined projection. Other one, Py means horizontal projection vertically, which is this case. Third case, small y, means local direction for this member. If you choose y, local direction in y direction is perpendicular to this member. Let's do an example. We have a truss, we have frame, 15 feet. this height 20, and this one is 5. We need to define dead load 2, live load 1, horizontal projection. We need to define wind load, this value, not written. Forget it. Yeah, you can assume this value, 0.5 pound kip per foot. This 1.6 kip per foot. This value 0.7 kip per foot. Any value. We need to define this claim on RISA, define your dead load, your live load, your wind load, and make our combination, finally to draw normal shear and bending moment diagram. What is the coordinate I will use? 0, 0, 0, 20, 25, 20. That's right?
Oh, it's above 5 feet, right?
It's 50.
No, I'm talking about the height.
5 feet, yes.
Yes, it should be 25, 25.
Yeah? It's 25.
Sorry.
15, 20, 50, 20, and 50, 0. You can define any cross section as you like. Let's see. So insert joint 0, 0, 10. I'm sorry, 0, 10. That's right.
20.
20. 25, 25.